In the spring of 2015, a team of graduate researchers from the University of Massachusetts visited the Bahamian island of Eleuthera to undertake an important renewable energy research project. The group is a part of the National Science Foundation's IGERT program, an interdisciplinary graduate research team tackling the different social, environmental, and technical problems related to offshore wind energy. We were invited to Eleuthera to work with the Center for Sustainable Development in evaluating their local and institutional potential for offshore wind energy. The Center for Sustainable Development, or CSD, develops models for sustainability specific to small island states. CSD also oversees facilities and infrastructure for the Island School, a hands-on, semester-long program for high schoolers, and the Cape Eleuthera Institute, a research center examining environmental issues facing the Bahamas and the Caribbean. Here we met with CSD Director Corey Broderick.
Hi, my name is Corey Broderick, and I'm the Director of the Center for Sustainable Development. We're one of 4 divisions down here in the tip of Eleuthera, with the Island School, the Cape Eleuthera Institute, and Deep Creek Middle School. Our goal, our vision, sort of the overall theme of everything that we do inside the Center for Sustainable Development is realizing that this campus is an amazing classroom, that what it takes to live here, to be self-sustainable, is a teaching opportunity.
We asked Corey why CSD is interested in offshore wind energy.
Pretty much from the beginning of the organization, there's always been a wind turbine on the campus. But the reasons that we keep looking, keep examining is the same reasons that anyone else does, is that, well, we might have a large 18-acre campus, we're out of space. And the footprint that our current wind turbine has it's massive, and it's taking up so much space, and nothing can go underneath it. And that leads us looking to the ocean just like anybody else does at this point, and seeing if there's an opportunity or a possibility that we could do that here.
The center currently has a 10-kilowatt terrestrial wind turbine and 61.4 kilowatts of installed solar panels. Our goal is not only to help CSD increase their renewable energy capacity, but to build a demonstration project which will allow for groundbreaking research and educational opportunities, many of which may be incorporated into Island School curriculum. Students would be immersed in the process of site selection and data collection, learning hands-on about offshore wind energy, environmental assessments, and climate change. From mangroves and tidal creeks, which serve as transitional habitat for fish and lemon sharks, to seagrass beds and coral reefs, which are home to countless marine species, to pine and broadleaf forests, which hosts many endemic and globally rare species, the Bahamas has a wide range of unique terrestrial and marine ecosystems. Many of these are already under considerable strain due to human activities and global climate change. It's critical to conduct a proper environmental assessment of these ecosystems and key species in order to minimize potential impacts associated with the development of offshore wind energy. The shallow waters of the Grand Bahama Bank could potentially allow for easier installation of offshore turbines, but the nature and distribution of patch reefs makes micrositing especially important. Whales and other marine mammals, sea turtles, and fish can be negatively affected by noise associated with turbine installation, and might also be affected by operational noise. However, if properly designed, offshore structures could potentially serve as artificial reef habitat. During operation, birds and bats may collide with turbine blades and towers. Specific lighting and curtailment schemes have the potential to reduce mortality for some species. Transmission cables bringing the power ashore also have the potential to alter behavior of sharks, rays, and other electromagnetically sensitive species, but little is known about these impacts. Where cables come ashore into the terrestrial environment, it is important to avoid impacts to sensitive ecosystems, such as wetlands, as well as important historic or current human uses. For example, a number of Lucayan archaeological sites sit along Eleuthera's tidal creeks. While looking at offshore wind energy for CSD, we also have to consider the bigger picture. The Bahamas is an island nation in the Atlantic, which imports most of its energy in the form of diesel fuel, which leads to high energy prices. With inefficient diesel plants, a distributed load spread across many islands, and a limited transmission system, the Bahamas presents many unique obstacles and possible opportunities for offshore wind. The Bahamas is highly reliant on tourism, so it is also important to evaluate the potential support or opposition from local communities and visitors in the development of wind energy projects. Initial surveys on Eleuthera have shown that, in general, people aren't happy with their current energy service and would be open to the implementation of renewable projects. It is important to do more detailed surveys and try to engage the local communities in the development of these projects. It is also important to consider alternative renewable options to offshore wind, such as solar or terrestrial wind energy. Due to a lack of site-specific information, our first recommendation for CSD is to deploy a research buoy to collect information on wind, wave, and tidal current data over the next year. During this time, the CSD can engage their students in the data capture, environmental assessment, and siting of a potential project. Once more information has been gathered and analyzed, the best turbine for the site can be selected and a deployment plan can be created. We hope to continue working with CSD as their project develops. The deployment of an offshore turbine in this context could be an invaluable research tool, generating a wide variety of data on the feasibility and effects of offshore wind turbines in tropical locations.